Hey guys, what's up? It's Mr. Fager coming at you for this video. By a request of a student, I'm working on solving systems by elimination. If you will notice, I'm using some of the work that we've been using with all things algebra. I'm working on homework 3, solving systems by elimination, day 1. Please note that. So I thought, what better way to actually practice working with systems by elimination than to actually do the homework that I assigned. So we will kind of work through this. It's hopefully shouldn't be a long video, but it's a clarifying video on what it is, what it means to solve systems using the elimination method. So I'll do a few problems on the front, then we'll do a few problems on the back. We'll move on from there, and hopefully you guys have a fantastic day, wherever you are. We're going to start off with number 1. Now remember that the goal overall of solving systems by elimination is to get rid of a variable. So whether it's x or it's y, we want to get rid of one of these. And to do that, we look for the coefficient that we have in common. Remember what the coefficient is. The coefficient is the number in front of the variable. Sorry, this only kind of works so well, but hey, we're going to make it work. So we have both x and y, but we want to find the number that they have in common. So whether it's x or it's y. So as I look at number 1, I'm going to clear off my writing here. As we look at number 1, we can look at x, and of course I'm going to point to x because x does not have a common coefficient. The coefficient on the first one is -1. The coefficient on the second one is +4. They're not the same, so we don't want to try and eliminate those because it's not going to work. However, on the y's, we notice that both y's have a +1. Those are our common coefficients because both have a 1 in front of them. So we're going to try to eliminate the y. Now the goal of elimination is to get rid of one variable so that way all we have left is the other. So we're only going to have one variable left after this, and that will enable us to solve for that variable, which we'll then substitute in. So then how do we eliminate? Remember that eliminating means that we can add or subtract one equation from the other, right? So we want to add or subtract. Since both of these have a +1 for the coefficient, we're actually going to subtract because we want this to come out to 0y, right? That's what we want. We want a 0y. So when we subtract, we're going to get that. Now that also means that we have to start up top and subtract from there. So -1 minus 4. Does that make sense? I'm subtracting the 4x from the -1x. So -1x minus 4x, that's a -5x. Then a +1 minus a -14, right? +1 minus a -14. Well, hopefully you know that two negatives make a positive, and that gives us a +15. So now if we simplify, we have that 0, because 0 times y is 0, equals -5x plus 15. Now we want to get the x by itself, because that's what we're trying to solve for. Remember, the goal of elimination is to get rid of one variable so we have the other one all by itself. We have the x, we just need it by itself so we can understand what it is. This is a two-step equation. I have to get rid of the, I'll even use colors. I have to get rid of the -5 and I have to get rid of the 15. Now which am I going to do? Hopefully you remember my saying if you've ever had class with me. This is like a Halloween movie. The first thing we want to do is pick off the loner because it's easier. So we're going to pick off 15 first. And to do that, we have to subtract because we're adding. So I know I'm running out of room here. Here's what I'm going to try to do. So this is going to be kind of weird, but bear with me. I'm going to blur the lines between reality. I'm going to create more space for myself. Now you can't tell me that's not cool. So for those of you, hopefully you are following along and you are writing this small enough that you have plenty of space. I know I don't. So I now have -15. Whoops. Let me fix that. Sorry. I now have -15 on the left side equals -5x. Now I know that I have to get rid of the -5. Well, this is -5 times x, so I have to divide. I divide by -5 on both sides, so that way the -5's cancel. -15 divided by -5 is just +3. So x equals positive 3. That's our x coordinate. Now this, we still have to solve for y. So we have to take this x equals 3 and plug it into one of our equations above. And we have to think which one is the simpler x to plug it into. When I say simpler, what I mean is we want to plug this x into the equation for an x that has the smaller or the more simpler coefficient. So when it comes to our coefficients up here, which is simpler, do you think? The -1 or the 4? Hopefully you're agreeing with me that the -1 is simpler than the positive 4, because we'd have to multiply 3 times 4. But if I just take this 3 and I plug it in here, I get y equals -3 plus 1. Now that's a lot simpler of a problem, isn't it? Instead of doing 4 times 3, then actually subtracting 14, we just now know that we have a -3 plus a 1. And the answer is -2. So my solution to this problem is 3, -2. I'm actually going to try and change this up here. I'm going to try and zoom in. But hopefully that first problem gives you a good idea of what we're trying to do. Let me see now. I want to do number 5, actually. So I'm going to try and take this, and I'm going to scroll up, and I'm also going to zoom in. I'm going to try and give myself a lot more space on this. There we go. So let me go ahead, and I'm going to find another color to do this in. Maybe, oh man, there's not a whole lot of choices, is there? I'll just stick with the blue then. I like my blue. Okay, so with number 5, the reason I'm doing this is because we can go either way. Remember, we're looking for a common coefficient amongst variables. As we look at this, we see that, well, both x's have a 1 in front, both y's have a 1 in front. So we could do either or. Either one we choose to eliminate will give us a pretty good setup, really. Now I'm choosing this because we can go either way. It's totally up to you. But if I were to tell you something, my suggestion would be to go with adding the equations. Here's why. You've already got a plus and a minus here. If you add these equations, the y's are going to cancel out as it is. My suggestion is to add. That way I get 2x, this is going to be plus 0y, equals -4 plus 2, which is -2. By adding these, because the y's already had opposite signs, the y's cancel out already. So I'm just left with 2x equals -2. So then all I have left to do is divide by 2. The 2's over here cancel out, and I'm left with x equals -2 divided by 2, -1. That's all that's left. So we now know that -1 is part of our solution. And now we have to take that and plug it back up in here into whichever equation we find to be simpler. So really the question is, which is simpler? In this case, both of the x's, again, have that common coefficient of +1. But if you want my suggestion again, I mean, you could go either way. But I want to take this and I want to plug it into this top one up here. Here's why. Notice that this y down here has a negative in front of it. That means we would have an extra step if we plug -1 into there, because we would have to divide by a -1. We want to avoid the extra work and give ourselves a nice simpler time. So, I keep using that word simpler. Please bear with me. We don't want to give ourselves much more work. One way or another, we would have to add the -1 to both sides. Do you see that? In either case, for either solution, for either equation, we'd have to add that 1 to both sides. But now, if I throw this in the top equation, I can just add 1 to both sides, and I've already got a positive y out front. Positive y equals -4 plus 1, -3. That is our solution for this equation set. Hopefully that made sense, how we can go either way. We can go either way, and that's totally fine. I just chose to do the things that I did because it would save me a little bit of step and a little bit of brain power. That way I can go on to the second page and do back. Now, if you're in my Analytical Algebra 2 class, you should already know that I've already said only do half of the problems, and that's okay. I wanted to do these ones on the back to illustrate something to you that I think is vitally important. And I think, as I'm looking at this, number 11 makes pretty good sense. What about, yeah, let's do number 11. Now, if you're looking at this, you can probably already see why I want to do number 11. Remember that the first step, and this is kind of a difficult thing to remember, but the first step is that we want to have our equations lined up. In other words, I want x over x and y over y, and I want the equal sign over the equal sign. Well, you notice with number 11, that's not the case. So what do I have to do? I have to subtract something or add something, could be either, to the other side so that I have x over x, y over y, equal sign over equal sign. So let's try and think about how we do that. Well, 5x plus 2y has the x and the y on the same side. And that's typically what we want, because when we eliminate a variable, we're going to get something plus 0 equals a constant. That's really what we want. We want to have both variables on the same side, so that way when we eliminate, we get some variable plus a 0 equals a constant, whether it's 3 or 6 or whatever it is. So that means if we want to have the x and the y on the same side, we want to work with this one up here. So I'm going to go ahead and I'm going to take a step, and hopefully, to get y to this other side, I have to subtract. So we subtract y from both sides. I should put a regular y here, just to illustrate what I'm doing. That way you don't get confused. I had a y plus 6, and now I'm subtracting y from both sides. So then when I do that, this y cancels out with this y, and now I have 5x minus y equals positive 6. Now this equation then I can bring down here, so I've got 5x plus 2y equals 3. Now we're ready to do our adding or subtraction, whatever it is. Hopefully you're looking at this and you're looking for the common coefficients now. Well, the common coefficients are not -1 and 2. Those aren't alike. But the 5s are. That means we want to eliminate x because they have the same coefficient. So what are we going to have to do since they're both positive? You guessed it. We're going to have to subtract. So we're going to subtract the bottom equation from the top. So when I do that, 5x minus 5 is 0. That's 0x. Then I have a negative y minus 2y. That's like owing $1 to Valerie and owing $2 to Caden, if I just wanted to throw some out there. So how many dollars do I owe in total? I owe 3. And of course it's negative because I owe people. That way of thinking about integers, that negative integers, owing people money, can be very useful. I always advise trying that. And then on the equal side, I have 6 minus 3. 6 minus 3 is 3. Hey, look at that. That comes out pretty simple, doesn't it? The 0 is just, well, the 0x is just 0. So I have negative 3y equals 3. And to get y by itself, because again, that's the goal. We're all solving. Solving is what we're doing. To get y by itself, I just divide by negative 3. So y is equal to 3 divided by negative 3. That's just negative 1. That's part of my solution. Remember, the solution is an ordered pair in this case. Now, let's think. I have to plug in the negative 1 for a y. So which equation of these two is going to be simpler? I hope you're saying the negative 1, because to multiply by the 2 would take a little bit more. It's easier just to plug in for a variable that has a 1 exponent. So I'm going to do this. I'm going to have 5x minus, remember that subtraction, that minus is separate from the y. So plugging in for the y, I have the negative 1. And that equals 6. Don't forget, when you have a minus negative, that becomes a positive. So I have 5x plus 1 equals 6. Now it's a two-step equation. And we have to get x by itself. So what do? Pick off the loner. So I'm going to subtract 1 from both sides, and I get 5x equals 5. Divide by 5 to get x completely isolated. x equals positive 1. That's our solution, 1, negative 1. Now, hopefully, some of these steps have really made sense. I'm really hoping that they have and you're starting to get it. To illustrate this one more time, because I'm like that, I'm going to go ahead and just go over and I'll do number 12. And I'm going to try and run through this as quickly as I can because I know it's already been like 13 minutes or so and I don't want to take up too much of your time today. But I did want to give you this definite good look into these. Ooh, I'll take purple. Okay. I like my purple. Don't mess with me. This is just another example of equations that are not on the same, that are not lined up, right? Because I have the 2x minus y here, and I have a y here, but the 7x is over here. Now, like I said in the previous problem, we want the x and the y to be on the same side, so why not just have it where we have x minus y, or however that goes. So I'm going to subtract 2x from both sides, or excuse me, 7x. So now, let me go ahead and bring this work over here. I've got 2x minus y equals negative 27, or 22, excuse me. 2x minus y equals negative 22. And down below that, I have negative 7x plus y equals 67. Simplistic, eh? Well, hopefully you're already looking at this because the next step is to find my common coefficient. And I hope you noticed already that 2 and 7 are not common coefficients. But in front of the y's, we do have 1's. So that's pretty nice. I could actually just use that to my advantage. So the y's are what we're going to try to eliminate. And notice that they have opposite signs as well. So that means I can just add these equations together. So 2 minus 7, well, that's negative 5. I've got 0y, right, because the y's cancel. And then negative 22 plus 67. Well, that's the same as 67 minus 22. Let's see. 6 minus 2 is 4. 7 minus 2 is 5. There we go. And because the 0 is what the y is with the 0, that just cancels. So negative 5x equals 45. All right. Divide by negative 5 to get x completely alone. X equals negative 9. That's part of our solution. Don't forget, that's the x coordinate. So negative 9, comma. We got to find the y, though. So which of these equations would be simpler to plug that into? Well, hopefully, you're already saying that top one. Or if you want me to go all the way over here, this one. We want to plug it into here because it's just a 2. 7 is much more to worry about than a 2. So I'm going to plug in my negative 9 for 2. Or I'm going to plug that negative 9 in for x. So 2 times negative 9, because that's x, minus y equals negative 22. Right? So then let's simplify this. 2 times negative 9, negative 18, minus a y equals negative 22. This is a two-step equation. So we'll start off by picking off the aloner because, you know, Halloween's coming up and I love that for some reason. You'd think I was a horror movie fan, but I'm not. So add 18 on both sides to get y closer to being alone. Negative y equals, that looks like a negative 4. Negative 22 plus 18. It's a difference of 4, but because the 22 is greater and it's negative, we have a minus. Now remember that what we want is we want a positive 1y. We want a positive 1y. So to do that, we have to divide by a negative. We have to divide by negative 1. The negative and a negative cancel. Y divided by 1 is just y. Negative 4 divided by negative 1, positive 4. There you have it. Negative 9, comma 4 is our solution. We're moving on. So I hope that this video clarifies a little bit more about the solving systems by elimination method, especially the elimination method. It can be tricky, but if we follow these steps, think about common coefficients, adding or subtracting, and then substituting in what we solve, it can get a lot simpler. So, like I said, I can't say it too much. I hope this clarifies anything. As always, you're welcome to email me at my email with questions if you need anything clarifying. But hopefully this gets you on your way and you feel a lot better about solving systems with elimination. I'm Mr. Fager. I'll see you guys later.